Okay, in this video we're going to cover section 12.2, techniques to evaluate limits. This will be covered in about 3 videos. All the bullet points for those 3 videos. We're going to find a dividing out technique to evaluate functions, or maybe a rationalization technique to evaluate some functions. We'll use technology like a TID9 to approximate limits of functions from the numerical table or maybe the graph. We'll evaluate one-sided limits. I kind of introduced that a little early in the last section. And we will evaluate some limits for calculus because that's what pre-calculus is for. So here we are, example 1. We have found this limit here. We're approaching -3. Numerator is a polynomial, as is the denominator. Of course, first, always going to try the direct substitution. Directly substitute the -3 in. We're going to get 9. 9 minus 3 is 6. 6 minus 6 is 0 in the numerator. That's not a big deal. -3 in the denominator is also going to zero that out. Now it is a big deal. Indeterminate form, so we cannot determine the limit from its current form. In the last section, we would set up a table or maybe look at a graph and try to figure out that limit as we approach -3. A better way, an algebraic way, is to see if we can divide anything out. The numerator is a polynomial. More specifically, it's a quadratic. We've been factoring those since Algebra 1. Now look at the denominator. You can't do much with it, but it's a clue as to how something might break down in the numerator when we factor it. Because if something isn't going to divide out, we're kind of stuck. So if we factor the numerator, numbers that multiply to -3 that add up to +1, that's going to be a +3 and a -2. If we try direct substitution again, we're going to zero out this term as well as this term in the denominator and be right back to 0 over 0. But what if we canceled? Divide out and cancel. So again, the original function gave us 0 divided by 0. We've manipulated the function a little bit. It looks a little different, but it's pretty much the same as the one we started with. We just algebraically factored and canceled something. Let's try direct sub again. -3 jumps in. -3 minus 2 is -5. There's our limit. If you don't believe me, you can go back and set up a table as you get real close to -3, like -2.999 and -3.001, and you'll see that the table will verify that that limit is -5. Example 2, it's also dividing out technique, but let's try here. First, of course, direct substitution. 1 goes in for x, 1 minus 1 is 0. Here's 1 cubed minus 1 squared, that's 1 minus 1. And then here is, we're going to plug in a 1 for that x, 1 minus 1 is also 0. So we still have the indeterminate form. Now when we look at it, the numerator can't do much with that. That's going to be x minus 1. But look at this downstairs in the denominator. I'm going to switch ink, come over here and do a little scratch work. Out of the first 2 terms, I could factor out an x squared, leaving x minus 1. Out of these 2 terms, I could factor out a 1, leaving alone the x minus 1. So if we factor out here, we're going to pull out an x minus 1, leaving the term x squared plus 1. So we cancel again. Now remember, up here in the numerator, there is a 1 as a placeholder. This is still going to be a fraction. 1 in the numerator, x squared plus 1 in the denominator. Direct sub did not work here. It took us to our indeterminate form. Direct sub here, though, is going to work. 1 over 1 squared plus 1, or 1/2. Again, we could do the same thing with a table and find that same value. And here's what the graph of that would look like. So there's our original function. Kind of looks almost like a bell curve shape in here. But as we put 1 in, we got 0 divided by 0. So above 1, our function did have a hole in it. But as we approached here from the left side, we were approaching this hole. The hole has a height of 1/2. If we come in from the other side, we would be approaching the same hole, also there at 1/2. So our limit is 1/2. Again, the function's not defined there. We have a hole in it. We'd float right through it and float off into space. But we can find the limit, or how the function behaves as we get close to that naughty number 1 that gives us indeterminate form. Here's a couple for you to try. Pause the video, see if you can find those limits, and then fire it back up and see if you got them right. Okay, first one, plug in the 4, 16 minus 28 plus 12, that's 0. 4 minus 4 in the denominator, that is also 0. But we can factor. I will use the denominator as a clue, x minus 4. So if I assume that is one of my numerator pieces, I know this has to be an x. What times 12 is 4? It's got to be a 3. And to get these to add up to -7, this also has to be a -3. We do our cancellation, and now we have changed our limit. Or not our limit, we've changed our function, or at least how it looks. Try the direct sub now. 4 minus 3 is 1. All right, here, direct sub gives us 0 divided by 0. But if we factor the denominator by groups, so here we're going to pull out an x squared, leaving an x minus 7 term. Out of here, we're going to factor out a 7. So that becomes an x squared plus 7. We do our cancellation, and then we direct sub. Let me write this out. We're approaching 7 again. 1 in our numerator, and then we'll have an x squared plus 7. So we direct sub in the 7. That's a 49. 49 plus 7 is 56. 1/56. Okay, now here's a different technique. This is also for rational functions, but if we look at this one here, we're not going to be able to factor that. So the book says a way to find the limits of some functions is to first rationalize the numerator of the function. It also could be the denominator from time to time. This is called the rationalizing technique. Recall that to rationalize a numerator in the form of a plus or minus b times root m, simply multiply the numerator or the denominator by the conjugate of that numerator. Remember, like here, a conjugate of root x plus 4 would be root x minus 4. The terms did not change, just the sign between them. Example 3, here's a limit. What do we do first? Direct sub. The 0 jumps in here under the radical. 0 plus 1 is 1, and the root of 1 is 1, so that numerator is 1 minus 1, or 0. Direct subbing in the x, we also get another 0. So there we have indeterminate form. We're going to have to try something else. Let me make this a little bigger. And we are going to multiply by the conjugate. Multiply. The terms are going to be the same. We're going to have a root of x plus 1, and we're going to have a 1. But this minus will change to a plus in our conjugate. And if we multiply the numerator by that, we have to be fair and do the same thing to the denominator. Let's do the denominator first here. And I would never distribute here. We might get a chance to cancel later. So our denominator is that first x times our conjugate, radical x plus 1 plus 1. Let's see what happens in the numerator. So we're going to sort of FOIL here. This radical times itself becomes the same x plus 1. And because we were under radicals up here, we'll keep that grouped as an x plus 1. In this case, it's not going to be too big a deal, but if we had a minus and we did that after the minus, we would have to distribute. So we do want to keep those as a group for now. If we FOIL the outers and the inners, they're going to cancel, and then we're going to have this -1 times this +1, so that'll be a -1. Okay, I'm going to bring back my limit notation. We were approaching 0. Let's see what we got up here now in the numerator. x plus 1 minus 1. Well, the 1's cancel, so we're just left with an x. Down in the denominator, ooh, it's good we did not distribute, because there's an x down there. We're going to cancel that in just a minute. But remember that we got that conjugate down there also. So there's that x times the conjugate. Now we can cancel. Again, don't forget there is a 1 up here with the x, so when we cancel those, our placeholder is that 1. Now let's try direct sub again. So our numerator is just a 1. 0 jumps in under the radical. 0 plus 1 is 1, and the square root of 1. Well, actually, I should just keep this as written out until we do the next step. Okay, now we're going to plug in the 0. So now it's root of 1 plus 1, which is, just I think we saw another one before that was 1/2. And we could also, again, go back and do that by an alternate method if we want to check our work. Here's the table that you would see for this same function in a TID9. And if we just really focus in right here on the sweet spot, we can see that we can't plug in 0 directly, but here's very, very close to 0 on the positive and negative sides. Here we're a little above 0.5. Here we're a little below. If we round this one up or if we round this one down, we're going to round both of them to 5. Or excuse me, 0.5, 0.5, 0.5, 1/2. Okay. Here's a one for you to try on your own, a checkpoint. Just multiply here by the conjugate. Now here it's going to be more critical. When you are multiplying by the conjugate, this radical multiplied by the conjugate radical will cancel each other out, but keep the 1 minus x as a group so you can distribute the negative. Pause the video, get your solution, check, see if you got it right, blah, blah, blah. So direct sub goes in. This turns into a 0. 1 minus the root of 1 is 0. Denominator directly becomes a 0 indeterminate form. So we are going to multiply by a conjugate. 1 plus the same radical. We'll keep the limit notation. We're approaching on 0. Denominator's x times the conjugate. Do not distribute. Numerator, first times first. 1 times 1 is 1. Negative times positive is negative. Radical times radical frees what's under the radical. Again, we got this negative, though, that we'll need distributed. So here we distribute the negative. That'll be a -1, cancel with this one. This minus times this minus changes it to a positive x over x times 1 plus the conjugate. The x's will cancel. So now we can direct sub in the 0. Numerator 1, 0 goes here. 1 minus 0 is 1. The root of that is 1. So again, we get another answer of 1/2. What's this? Okay, that's right. There's another technique. We had the rationalize and divide out technique. Here's one with fractions within fractions. And all we're going to do is, combine the numerator here into one fraction. Again, it's kind of sad the book doesn't have an example on this. I did pick up homework problem 15 because you will have one in the homework tonight. It'll probably be number 16. So let's see here. If we try direct sub, 0 goes in, so this becomes a 1 over 1, which is 1 minus this one is 0. Denominator directly becomes a 0. So we got to try something else. Up here, we have two terms. Let's get this to be one fraction, then we can bring this denominator up and flip it. So just as a real quick refresher, remember for two fractions like this, a over b minus c over d, a real quick way to do it, multiply these denominators. Your denominator will be b times d. Multiply up this way, a times d, minus this way, b times c. So if we do that little technique here, our denominator is going to be 1 times this, x plus 1, or that just makes it x plus 1. And our numerator, if we multiply up this way, 1 times 1 is 1, minus this 1 times the quantity x plus 1. Let me switch over to red ink for this down here. We'll keep that as x over 1. So let's see. Up here we distribute the negative. That is now a negative x and a minus 1. So that minus 1 will knock off this plus 1. And up here is just a negative x over this quantity x plus 1. Down here underneath we have this x over 1. And now is the perfect time. How do we divide two fractions? Invert and multiply. So we're going to bring this up and flip it, and it's now going to be a multiply problem, 1 over x. Now look what happens on the diagonal here. Let me circle that in green ink. Those x's, minus the negative, are going to cancel down to 1s. So we have our limit. I should have stuck with a different ink. The limit as x approaches 0. Let's see what we're left with here. Again, on the diagonal, these are going to cancel to 1s. So we're left here. This will be a 1 with a negative in front of it. And then down here in the denominator is x plus 1. X plus 1. So now we could do, again, direct sub did not work on the original. Let's try direct sub here. So our numerator is negative 1 over 0 plus 1 is 1. So that's just negative 1 as our final answer. There we go. The homework. This is on WebAssign. If you're having any internet troubles or trouble with the WebAssign website itself, textbook page 837, these 5 even problems. I hope this video helped.